This time I'm going to show you how do we draw the electric field line for the parallel plate. So let me just review a little bit what we discussed last time. And what we said was that whenever you have electric field line, you want to draw them, electric field line must have these arrows. And the line must be smooth. It should be a straight line, smooth, or continuous lines, curved lines. It start from a negative charge or end up or start from infinity, or ends at negative charge or ends at infinity. And also the number of lines must be proportional to the amount of charges. I redraw some of these figures. So you can see, for instance, if I have two negative charges, so the field line has to go toward it. If you have a negative 2 microcoulomb, so you have a 1, 2, 3, 4, total 4 lines. If so, negative 1 microcoulomb, you're going to have 2 lines. So these must be proportional. Anything between these two boson negative charges should be no lines. Similar case is also true if you have both are positive charges. The line try to avoid each other. So that is what we discussed last time. Today we're going to talk about a parallel plate. In other words, what we are interested in, what happens if we have two plates parallel to each other. So first I'm going to draw these two plates. So this is my first plate, and this is my second plate. Now, when we draw these, we input say they are infinitely long. It's extremely long, and but in physics, there's nothing that is infinitely large. So we always draw the plate at one particular end like this. It's very short. And then I'm going to put some charge on that. First, I'm going to, let's say, put 3 charges on the left and then draw 3 negative charges on the right-hand side. 1, 2, 3. So I totally have 3 charges. And the left plate also has 3 charges. And these must be exactly the same amount of charges. Otherwise, the plate will have excessive charges that are going to be appears maybe on this side will appear. So therefore, that is not we are going to consider. When we draw field lines, and it's very crucial, if you have one positive charge, you remember the positive charge like this, right? The field line goes away from like these ones, okay? But if you have 2 positive charge adjacent to each other, what happens was these components, when it's going down, another charge going up, these two will be canceled out. Similarly, for these ones, also will be partially canceled out. Only thing that is remaining is point for that direction, which is perpendicular to the line linked these 2 charges. So therefore, in the middle, you're going to see a straight line like this. Let me erase this. I want to just draw with a little better pen. So it should be a complete straight line, perpendicular to the plate. Because what happens was that for these charges, you see this particular component is, you see you have a little bit y component here, but for the charge on the bottom, it will have upper component. In other words, the upper part of the component, the down part of the y component, they all cancels out. Only thing that is going to remaining is the x component, which is pointing this direction. So that's what I have. However, it's no longer the case if you have a charge at end of these. At the end of these, you see the cancellation won't be complete because there's no charge here. So therefore, the field line will more or less like this line, but since we have another negative charge on the right-hand side, so you're going to see the field line look like this. So there is a difference. And these kind of field line, we normally call it edge effect. It has kind of a around the edge, and you always have these effects comes out. In the middle, it's just completely uniform, just reinforce the idea. If I have one more charge over here, I would have arrow like this. Let me keep on finishing up. But when you start to close the edge, and then it won't be the case. You know, it's close the edge, start to bands like these, start bands like these. So that's why you must make sure if you have a parallel plate, and it's going to behave like this. in our experiment, in the real lab, and you're going to see these lines realistically. So we're going to have a similar lab to just show you. So just remember, if you have parallel plates, field line look like this. And so next video, what we are going to show you is we can show additional things about the magnet, sorry, not magnet, electrical field magnitude.